Welcome all. Welcome to the presentation Microsoft Office in Wonderland. My name is Peter. This is Stan. We will take you along on a journey into Office. We are red teamers, for Outflank, a small company in the Netherlands. We perform adversary simulation, advanced pen testing. And in that process, we often use Microsoft Office, one, to write reports, but also to send malicious documents to our clients, to our targets. And in that process, we always rely on standard tricks like Office macros and DDE for code execution. But we've investigated Office in a broader perspective, and we've looked into other features of the Office suite we can abuse, and how we can just bring this further, just taking Word and Excel and see what other malicious uses we can take from in our attacks. So the first question is, if we take DDE and macros, we always look into code execution. But do we actually need code execution? So what can we do with a system if we don't do code execution? For that, let's look into one of the demos. Let's try to steal credentials. So this is a web server running, and on the web server, it only gives a basic authentication response. And then, so that's my attacker system. And then on the user system, I send the user a specific backdoor document or a malformed document. And then the user will see, will have the following behavior. So he opens this document, which was just sent by email. And the user suddenly gets a prompt, a username password prompt. And it says, well, this server reports that it needs a password for Outflank, and the user just types in his password, his username. And in my attacker system, I do get the username and the password being provided. So from a user perspective, this looks just very standard. This looks like SharePoint asking for the password. But something different was happening here, because as an attacker, I just stole the password. So what happened here is a trick which relies on fields. And for fields, we need to dive into a bit deeper into Office. So if we go into Word, there are some hidden old school gems. And one of the old school gems is, if you go into in the insert mode, there's this quick parts button. And if you just start clicking around in Word, which is kind of how our research is, we just click around in Word and we try to find nice features, you'll see there is a fields button. And this fields button, it has a lot of additional options and features here. You see, you can have the author of the document as a field, you can have an include picture, you can include all other interesting things. So one of the interesting things you can include is an include picture. And what you can say is, I want to have a picture of my malicious host. So it's just an HTTP URL, you can type it in here. And on the HTTP URL, you can say, well, I want to have this include picture to be dynamic. So I don't want this picture to be stored within the document. I want this picture to be a dynamic retrieval of this URL. And with that, in Word, next time a user opens the document, it will load the picture. Well, that already is a very simple trick for us to use as a watermarking, so we know, as a tracking pixel, we know when a user opens a document. So that's kind of also where this research started. We were just playing with these fields. And there are quite some interesting fields in this one. So we have include picture to retrieve remote content or to retrieve a picture from a remote location. We have a username, user addresses, all kind of attributes. And they are typically used in the old school way of how to use templates in Word or in mail merges. So if a user opens a document, these fields will get updated. So include picture, I just mentioned, that's very valuable for tracking a user whether he opened the document or not. But if we go into the demo I just demonstrated, this is about credential theft. So how does that work? Well, this is a combination of multiple layers of fields within each other. And this is a CVE. Microsoft patched this in January. So we reported it. It took them a couple of months before they could patch it. So what this is an include picture, just the same as this standard picture we often use as attackers. But in this picture, we said this URL contains this username field. And the username field is dynamic. And we don't store this in a docx file, but we store this in a .x file or in a .dot file, which is a template. So when the user double-clicks it, the username string gets updated. By doing that update, the URL gets updated. And by doing that, suddenly the request of the web server does process basic authentication responses. So where normally, if you would have an include picture with a basic authentication response, it would just ignore this. By doing this trick, so it should be in the header, it should be a dynamic URL, and we do this by including this username field, and we use a .x file, we suddenly have this nice credential pop-up. And the nice thing is, as long as we, as an attacker, keep giving failed authentication responses and ask for new credentials, the user will keep getting prompts. So the user can't open Word until he just gave the last 10 passwords ever used. So this is CVE of 0540. We have another one, which also relies on fields. So credential stealing without macros and without code execution is nice, but maybe you want to steal files as well. And for that, there was this, in 2002, there was this CVE in Word, which used a quote and then a file name and an include text. And this include text field, you can use it to include text from a text file on disk. So you can say include text, see the semicolon, slash, dash, and a text file. The patch Microsoft made was to just not update this field anymore. And our challenge was, how can we get this include text to update? And again, by using these fields, which is like real legacy, old school stuff, we managed to do that. So this is again my web server running on the back end, which just runs a standard web server in this time. So this time it's not running this basic authentication responses, just a standard simple HTTP server. And we send the user the following: double click to see the monkey dance. And if the user does that, he double clicks the file, well, actually nothing happens. But if we now look into our web server, something interesting has happened. We just got this huge blob back, and if we look carefully, this is just the URL encoded version of the unattend file of that specific system. So in this case, there were no clear text passwords in this unattend file, but we just stole this unattend file by just a user double-clicking a monkey. And again, this relies on fields and a combination of fields by multiple layers. So how this one is built up is it's multiple layers. So we have an include picture with a monkey, but next to that we see another include picture, which points to a malicious web server, and then an include text. So if this field, this include picture field, so this picture would be updated, we would send the text of the unattend file to this malicious web server. But now we just needed to force it to update. This Microsoft's patch said, well, we won't update this include text anymore. And for that, we used yet another field, and that field is named a macro button. And macro buttons have not really something to do with macros, as we know it from VBA. This is just a field, and it's just a button. It doesn't look like a button, but in the Word context, it says it's a button. And what that means is, if you select it, you select the full macro button, so you can't select something in it. So as you see, when you're double-clicking, you'll see that there's a bigger building block selected, which is the button, kind of the context. And once you double click that one, all the content of this macro button is being updated, which then updates the monkey picture, not that interesting, and it updates this web server and this unattended file, sends it an unattended file. So this is again a way how we just by ingeniously combining these very legacy fields, building them into each other, trying to take different events, how we could steal arbitrary files by just a user double-clicking something in Word. We've submitted this again to Microsoft. Again, took them 3 to 4 months for patching because they had to change something deeper into Word. And the mitigation of Microsoft turned out to be an additional security warning. So anybody who is now using an up-to-date version of Office has this new warning feature introduced that this document contains fields that can share data with external parties, and it is important that you only open such a file from a trusted location. So that's 2 things we already did in Word, which like legacy features, no code execution, and still we can do stuff which we really don't want to happen to your users. These were the legacy features, but sometimes we just get new features being added to Excel and Word. And for that, we need to meet M and the get and transform abuse. So on a day, I was opening my Excel, and I saw this pop-up. Need to import data, we just have this new feature. It's called the get and transform wizard, or get and transform feature. Turns out to be that Microsoft has ported various features of Power BI into Excel. And they name it Get and Transform, but it's very much relating to Power BI. And in Power BI, you have this scripting language which is called M, so therefore meet M. This is like the newest features of Word and Excel, so that's also very interesting from a research perspective to look into, well, how can we make abuse cases out of this one. Let me go here. So this is again my simple web server. I open just a standard Excel file. It will give me a security warning. And if we go into the Excel menu, we can see which warning this is. This is not about macros. This is about a web service and about external data connections. So we think we open an Excel sheet which just opens external data connections. That's hopefully where we need to convince our user to click that, or the victim to click that, or to believe that this needs an external data connection, but it's way less invasive than a macro warning. What now happens is the following. There's a get and transform feature, and the get and transform feature can import from text files. And well, if you can import from a text file, well, then I can read from any text file, which includes, for example, this unattended file. And then we need to submit it. So on this screen, we'll see that all the data has been submitted. This is again the unattended file, which has just been stolen by an attacker via a malicious web server. How this one works? So we have a get and transform, this new feature of Excel, and we have this definition in this M language, which says, well, dear Excel, can you please read this file, C unattended, and consider it a CSV file, and put everything in the first column of this specific Excel sheet. And that's what happens. The first column is getting filled with the data of my unattended file. But then, as an attacker, I want to steal that data and I want to send it away. So that brings the second layer of attack, which takes this field from A1 and just sends it with a web service request. And this web service request has a maximum length, so we can't post this one unattended file in one go because it's too big. But we just take line by line, we post that data away. This was a very naive example of stealing an unattended file. So this get and transform wizard has a lot of features. One of them is it can import text files, just txt. And this is what I use in this demo. but you can also use it to parse to retrieve XML, and you can just really define like an XPath query and only get a very specific value, which makes it much faster and much less less in your face. And furthermore, there are so many more features in this new wizard, in this new get and transform stuff. So you can make database connections from an Excel sheet. You can make connections to Azure, connections into the Active Directory. So it's ongoing research, but I really believe there's a lot of potential here to not do code execution, or maybe use this feature to get into code execution, but do something besides the DDE and besides the standard VBA tricks. So these were 3 tricks that have nothing to do with code execution on systems, but already stealing files, getting credentials from users. So that's already quite nice achievements. But the next part is, do we actually need VBA for macros? Do we need that? And that's where Stan comes in.
Yeah, so what we're going to do is we're going to have a look at the go-to technique for most attackers in abusing MS Office, which is still macros. But we are going to get it to the next level, because there is so much happening under the hood of macros, and we're going to have a look at that. So we're going down the rabbit hole of macros. And the first thing that I have to explain to you is that macros is not just VBA. Most people think when they hear macros in MS Office that it's Visual Basic for applications. But there's other languages that are supported as well, and the most important one there is XL4 macros, or XLM macros, which I will be dealing with in a minute. And the really interesting difference between VBA macros and XLM macros is that VBA is a separate engine, is a separate DLL, which can be blocked by AppLocker, for example. But XLM macros are processed within excel.exe itself. It's not a separate engine, it's within the exe of Excel. So that will be really hard to get rid of in your environment. And then VBA is not VBA. There is stuff happening under the hood. There's intermediary languages under the hood of VBA, P-code and Xcode. I will not go into Xcode, but P-code we will dive into in a few minutes, which is really interesting as well. So that is what we are going to do in the next 20 minutes. Let's start with XLM macros. XLM macros, they exist in Excel since 1992. And if you've never seen it, this is how it works. I just go to Excel, right-click, insert, and I actually choose, I'm going to choose this one, MS Excel 4.0 macro. All of a sudden I get a new sheet, and this is a so-called macro sheet. And this language is completely different from VBA, so let me write an example, exec calculator, and then halt the macro after that. And if we run this, then there's my calculator, that's how it works. And if I want to auto-open this function upon opening this file, I just have to rename this cell to auto-open, and then it just behaves as a regular auto-open event in VBA macros. But again, a completely different language, which is being ran by a different engine. And if you want to hide your macro, right mouse click, hide, and it's actually gone from the GUI. So this is some basic stuff which we already demonstrated at DerbyCon last year, but it gets more interesting if you go deeper into this. So I just started calculator with a simple exec function, but I found out that you can actually call Windows 32 API methods as well. So this is an example of shellcode injection into the current Excel process by calling virtual alloc, write process memory, and create thread. It's a basic proof of concept. You can make it much more advanced, but it does show you the power. Excel 4.0 macros are almost as powerful as the regular VBA macros are. And if you want to hide your macros even better, then let's have a look at the file format specifications of Microsoft. So if you look at the file format specification of a sheet, so you have a regular sheet, but there's also a macro sheet. But each sheet has a few options, and they are being set in this bound sheet 8 record, which is in an Excel file. And there's the option, which I highlighted on the bottom. So there's a regular sheet, which is visible. There is a hidden sheet, which I just made hidden with a right mouse click. But actually, if I want to unhide it, then I just go back, and there should be an unhide button here, and then all of a sudden, my macro is back. But apparently, there's also a specification which says very hidden. And it took a little bit of Googling, but actually, this can be achieved really easily. So you just first write your XL4 macro, then open the VBA editor, just run a single line of code, and set this sheet to very hidden, and then all of a sudden you cannot unhide it from the GUI. Then you remove this VBA code, save the file, and now all of a sudden you have a completely invisible macro. And it didn't take very long after our DerbyCon presentation before these things started popping up in the wild. And actually we had to find out of this specific setting by abuse of this feature in the wild. And this is the actual sample that's there. If you look this sample up, it does process injection. It has a very hidden sheet. And this was after our disclosure at DerbyCon, but still 0 out of 59 detections at virus total. So current visibility of virtually all virus scanners into this really old 1992 technology is pretty poor. This sample was pointed out to the excellent team from Mnemonic, by the way. Look up the hash. It's a really cool example. It's way better than our proof of concept that we released. This is the stuff that we're seeing in the wild. Excel macros are not just exposed via Excel files, via workbooks and sheets, but they are also exposed via something called Silk. And if you're not familiar with Silk, Silk is a text-based file format from the 1980s. They are still being used in Excel, or they are still allowed in Excel by default to be opened. And even the SLK file extension is by default connected with Excel. It's a completely text-based file format. And because of that, it does not open in the protected mode sandbox. So you might be familiar that after downloading a regular Excel file in the default setting, you have to click Enable Editing to get out of this protected view sandbox. Because Silk files are completely ASCII-based, Microsoft has decided that they do not open in the protected view sandbox. So that's a good thing to begin with. And that actually, what you see there is less than 100 bytes. It's 99 bytes to pop calculator via Excel 4.0 macros within a SLK file. Then the MDSec team from the UK, they took my sample code and they actually embedded this into their tool, Sharpshooter, which I think many of you are familiar with. And they now fully weaponize this. And I've heard from various teams that this technique is pretty successful and that current visibility of antivirus into this is pretty poor. So we've now seen XL4 macros in regular Excel. We have seen them being exposed to Silk, but there's more places where XL4 macros are being exposed to. One of the interesting parts is COM and DCOM. So you have this method, execute XL4 macro, which is exposed via COM and via DCOM. And this means that if we open it via DCOM, we can actually run XL4 macros without touching disk on a remote system. That's the whole principle of DCOM. So what you see here is a few lines of code, a simple proof of concept. And what we do here in the first line is we instantiate Excel on another system, on server 01. That's just default DCOM functionality. And then we have an interface with Excel on that other system. So we're going to use this for lateral movement. And then by just executing XL4 macro calls that subsequently call Windows API calls, we can now inject shellcode on a remote system without ever touching disk, which is a big plus over many other DCOM-based lateral movement methods that are currently out there. There's one big con. It's pretty slow, so injecting a shellcode of 1,000 bytes, each staging shellcode will take you about 1 to 2 minutes. But if you have that time, then this is a really great method to actually inject shellcode, do not rely on any lol bin, and inject it into excel.exe on a remote system without touching disk. Code in PowerShell and a Cobalt Strike implementation is at that GitHub repository. So that was Excel 4 macros. Now let's go back to VBA macros. And if you look at the specification of VBA macros, you get stuff like this. This is what Microsoft released. And if you have no clue what this stuff is, then let me open up a Word file for you. So I have a .doc file here. And if I open it with a compound file editor, then I see this. So what this is the compound file binary format, CFBF, also called compound files. And they are like a file system in a single file. This is the default file format for Word files until 2003. And after 2003, they switched to a zip and XML-based format. But even if you open the newer formats, like docm and XLSM, in a zip archiving program, then you will see a file there, VBA project.bin, which actually contains the macros, and that in turn is a compound file like this one, and you can open it, for example, with FlexHex. So what you see here, I'll zoom in a bit, is there's a storage called macros, another storage called VBA, and within here there are several streams. I'll quickly explain these streams. Project basically informs the GUI on what to display, the VBA GUI editor. VBA project informs the VBA engine, not the GUI, but the actual engine, about what kind of VB project this is. Then there's a dir, which is like a layout of the project. And there are module streams like module 1 and this document in this case. And for example, if you look at module 1, then it's just hex stuff like this. Well, I'll stop scrolling. And this module stream, that is what is being specified here. So this is the MSO VBA specification, and this specifies the module stream. And it basically consists of two parts. The last part is compressed source code, which is a proprietary compression method that just compresses the VBA source code. But there's also the first part, performance cache. And performance cache is completely undocumented. And Microsoft actually says it must be ignored on read. Well, clearly, Word and Excel, they don't ignore this on read. They're doing something different here. And that is P code. There is a layer under VBA for the VBA engine where there's some sort of intermediary code. And if the file version of the Excel or Word file matches the version of the Word or Excel host, then the VBA code is completely ignored and the P code is being ran instead. At our DerbyCon presentation, we had some details about this, but we have now actually weaponized this. And we're here by introducing Evil Clippy. So we brought Clippy back. It was time for him to revive. And Clippy will help you with creating malicious documents, especially around abusing P code. So immediately after our presentation, we will upload the code to GitHub. And what Evil Clippy does, it can hide macros from the GUI editor, it can do P code abuse, etc. And I will give you a few demos so that this all makes more sense. Where shall I start? Yeah, I'm going to start right here. So this is Cobalt Strike, which some of you might be familiar with. It's a C2 framework, and it has an implant called Beacon. And it also has some basic attack techniques. For example, if I do packages, MS Office macro, I can generate a malicious macro here. Copy macro, yep. And if I look at the contents of this macro, is insert module. This is the actual macro. It's really basic. It doesn't do any evasion. I would not recommend you to ever use this on an engagement. And what it does is it kicks off run DLL32, and then via the Win API, it injects shellcode into this process. Really basic techniques which are clearly malicious. So if we upload this file to VirusTotal, which I just did before the presentation, then we can see that all major antivirus engines, that they do detect this file as being malicious, obviously. So now let's try what we can achieve with this obviously malicious macro by abusing this functionality which is under the hood of VBA, this P-code stuff. So we're going to evil Clippy. Here's evil Clippy. And the first thing that we are going to do is I'm going to copy the original file, CS original. I'm going to copy it to CS hidden. I'm going to say evil Clippy, please hide the macro from the GUI editor. Yep, so we now have a new file. And if I open that file, and I run macros, then I should see a new connection coming in at my Cobalt Strike team server, or is it? Yep, so I do have a command and control session right now. The macro is successfully executed. But if I go to the macro editor, the macro has completely disappeared. It's not there anymore. Evil Clippy achieved this by editing the project stream in the CFBF file, which instructs the GUI on what to display. So it's hidden from the GUI editor, but the macro is still there, and we can easily see that with a tool called OliVBA, for example. The macro is still there, it's just not being displayed in the GUI. So that's feature one. Now let's try to get rid of the macro as well. So we're going to say, we're going to have some fake code. This is some fake code, just a simple subfake with a message box. And I'm going to say, evil Clippy, first of all, I need to copy the file, black hat, original to P code. Evil Clippy, do not just hide the file, but please also remove the compressed VBA code while still leaving the P code intact. And do that on this file, CSP code. Okay? So if we now run OliVBA on this file, we will see that OliVBA thinks that the code in this file is, hi, this is fake code. But if we open the file on this system, we do enable content, we run the macros, and we go back to our Cobalt Strike team server, then we see a second connection coming in. So it's not the code, the VBA code that's being executed now, it's a P code, because the version of this file matches the version of Word and Excel as well. With Evil Clippy, you can actually set the target version of Office to target, like 2016, 2013, 2010, whatever is there. But, there's a big but, there are tools that can analyze P code. And the most famous one is P code dump from Dr. Bonchev. And if I run P code dump on this file, then P code dump still sees that there's a P code macro in here. And you see that it's starting run DLL and doing all the bad stuff. So this can still be detected. Then how can we get rid of P code dump as well? For that, we dived into the specifications of how macros are stored in a file. And it turns out that Microsoft often has two names pointing to similar objects. And if an object is a module stream, then it keeps track of the module stream in two variables. One is an ASCII variable, and another one is a Unicode variable. So there's two different names pointing to the same object. Well, what could go wrong? Thing is that what Microsoft Office uses is the Unicode name of the module stream, whereas most security analyst tools use the ASCII name. So what we can do is we can edit the file with Evil Clippy, set a completely random name for the module stream in ASCII while still leaving the Unicode name intact, and that's exactly what I'm going to do now. So I'm copy it again, random.doc. I'm going to say Evil Clippy, yes, hide it from the GUI, set some fake code in there, but now also do random random module names for the ASCII specification. CS random, okay, it did that. It set random ASCII names while still leaving the Unicode names intact. And if I now run CS random, I'm going to show you that it's all still working fine in MS Office. Enable content. And we should see another connection popping in. There's another connection popping in, so that's working just fine. But if we now launch pcodump on this file, pcodump all of a sudden says error, file not found, because that uses the ASCII name. There's plenty of more stuff that you can do here, but this was just a basic demo of what Evil Clippy can do. And the question is, how effective is this? So we started with 34 engines detecting this obviously bad macro. And I just uploaded the last version to VirusTotal as well. And then we got rid of all major antivirus engines. There's only one, which is Siren, which actually triggers on a string, which is still in the P code, so that wouldn't be too difficult to get rid of as well. So antivirus has a really poor visibility into P code. And I can understand why, because there is no official specification of P code. So it would be really difficult to get proper optics into this. There's one other thing which is interesting that's happening. If you look at the details of the original file, then VirusTotal detects that there's macros in here. But VirusTotal also suffers from this ASCII versus Unicode bug. Because if we go to details here, it doesn't see any macros, because this is processing the ASCII module stream names instead of the Unicode module stream names. Cool stuff. So this was a journey down the rabbit hole of macros. But on modern instances of Word and Excel on Windows 10, you might run into modern defenses like MZ and ASR. And we're going to show you some basics on how to bypass these as well. So Peter will start off with MZ, and then we'll take over with ASR.
So MZ is the anti-malware scanning interface introduced in Windows 10. Microsoft hooked up a lot of script interpreters like C script, PowerShell into this interface, and the script engines send all their events that they execute to this MZ interface. An antivirus vendor can subscribe to that, and any PowerShell command you execute gets first being approved by the AV vendor, or the AV product can then intercept if it wants. In September, Microsoft announced that they were also doing MZ for VBA. And as of January, this is part of this semi-annual release, so that means that in most of the Office 365 deployments, this is now live and working. In the design of the VBA for the VBA MZ interface, they made a slightly different design than for the PowerShell and C script versions. So what they do is they say, well, we maintain a log of all suspicious calls, being the suspicious calls being COM methods and Win32 APIs. They say, well, we will just log all of these requests being made in runtime. So anytime you create a new Word instance in a macro that is being logged, that's just a log file, a behavior log, which they kind of keep track in like a stack trace. And then they say, well, there are a couple of suspicious events. And once we encounter a suspicious event, then we go into a trigger mode. And at that point in time, we will take this stack, this log, from Word, or from the VBA engine, and send it to the MZ provider, or to the MZ engine, and then the AV can decide. On the design, Microsoft said this is about VBA. When testing it, it turns out to be that P code is also intercepted by MZ. So stand strict on P code and removing the VBA code. This MZ engine, would still, being a runtime engine, it takes the P code and provides that to MZ. One additional detail they described in their September blog about the design is that there's this macro runtime scope. So Microsoft was worried about performance and how this would affect regular macros being executed in businesses. So what they said is, well, we'll have three versions of this three modes where this engine can run. One, it can be disabled. It can be enabled on low trusted documents, and it can be enabled on all documents. And low trusted documents, they said, well, we will just exclude documents that are in a trusted location or that you looked at it before, so trusted documents, so a document you opened before, it was then analyzed, and the next time you open it, we won't analyze it again. If the document is signed, so these kind of things, they say, well, if it's that, then we'll just exclude it from MZ, so that keeps performance intact. We will only check it the first time it runs. And this low trust document mode is the default. So if you don't configure this setting, by default, the first time you open a document, it will be sent to MZ. So in terms of, this is how Microsoft designed it, and there are quite some fundamental bypass approaches in how they set this up. So first of all, how to bypass MZ? Well, let's just don't do VBA. So where we started the presentation, fields abuse, power query, or this get and transform, it's not code execution, so it won't be picked. But also the Excel 4.0 macros Stan demonstrated, they are not in the VBA engine. This is a separate engine. So that engine is just not hooked up to MZ. So doing Excel 4.0 macros is fully bypassing MZ. Then there was this feature with this macro runtime scope and trusted documents. Well, if we can write our document into a trusted location, we can just drop our code there, and then we reopen our own file from the location where we just saved it. And MZ will say, well, you're now from a safe location, so no worry to check this one. So again, a very simple way to bypass MZ. Then there's this decision not to send everything from COM and Run32 to this MZ engine, but only build up this stack within the VBA engine and send it on specific malicious keywords. Well, it appears that this list of malicious keywords is just if it contains the word shell or execute, then it's being sent to MZ. And if you have COM methods that don't contain the word shell or execute, you may be able you can run them and it won't be sent to MZ. It will still be in this log, but it will just never be sent to the AV product. So examples of that are execute Excel 4.0 macro, DDE initialize, or WMI spawn instance. They're all words which don't contain the word shell or execute. And then a fourth category exists, that is, there are features in Word and Excel that are not per se COM or not Word Win32. So how about we create a file in Word, a macro, and the only thing the macro does is write something in a Word file, save it as a text file, but as a text file format, but with the extension .bat and the extension .reg. And if we do that in a smart way, we drop that in the startup directory, then suddenly we have, we just drop a bat file which says import this reg file, and in the reg file we say disable the MZ engine or set this macro runtime scope to disabled. And this is all stored in HKey current user, so that's very nice for us. We can write there. So the next time the system reboots, we just disabled MZ for Word, and we can go along and have a lot of fun without MZ intercepting.
Yeah. So what we're seeing is that the MZ implementation for VBA is much weaker than the MZ implementation for PowerShell, for example, and that is just by design because it works with logging and triggers, whereas the PowerShell MZ just catches the whole script. This is completely different, and we already see that there is a few basic techniques by which we can bypass this. But on a properly hardened system, you might also run into attack surface reduction. And attack surface reduction are rules that are enforced by Windows Defender Exploit Guard, which is the successor to EMAT. And there's a few rules which can harden Office and Excel and other MS Office programs that are running. And the most famous rules are the rules to block Windows 32 API calls and the rule to block Office applications like Word and Excel from creating child processes. So block them from starting other programs. It's not that difficult to get to bypass these two. The first rule, block Windows 32 API calls, it's a static rule. So Windows Defender Exploit Guard just scans a macro if there are any VBA signatures for forbidden Windows 32 API calls. So how can we bypass this? Well, we can actually go from VBA to Excel 4 macros and thereby call the Windows 32 API call dynamically without having to have a VBA signature for that Windows 32 API function. You see a few lines of code that do just that for shell execute A with calc. For the other rule that's there, block Office application from creating child processes, that's a dynamic rule. So that's enforced during runtime. It's not a scan of the VBA code. And the whole trick there is to let the dirty job of starting another process to be done by another program. For example, a running instance of explorer.exe. So what this code example on the bottom does, it just queries a COM interface to shell browser window, which happens to be a part of explorer.exe, the running instance of explorer.exe, the actual shell, and then we can abuse the method shell execute, which Explorer offers via COM, to have Explorer start calc.exe. So now Word or Excel interfaced with Explorer.exe, no process creation there because Explorer.exe was already running, and we have Explorer.exe spawn a child process. Well, you can do these kind of tricks both with COM and WMI, but these are the most famous ways to bypass ASR. This concludes our presentation, and what we have shown you is that there's both archaic features like Excel 4.0 macros and fields that can be abused, but also new features like Power Query with the M language, which are really promising for abuse as well. And we have also shown you that these features can be abused in all stages of an attack, from code execution, antivirus bypass, but we've also shown you that it can be really interesting for lateral movement and bypasses of modern defenses like MZ and ASR. We pretty much love MS Office from an offensive perspective. We've only scratched the surface, and we really hope that we've given you some insights not only on how to abuse this kind of stuff, but also provide interesting angles for future research, because really there is so much more, both old features and new features being added. It's basically a goldmine. So thank you all for listening. If there are any questions, I do think that we have a few minutes to answer them. I see a hand there. I don't know if there's a microphone. If not, we'll just repeat the question. Would disabling macros actually stop all this? Yes and no. Yes, as in both P-code and Excel4 macros, they do adhere to the settings. And you're actually talking about the trust settings. So if you go to File, where do I have it? Options. And then go to the trust sender settings. These settings can be managed via GPOs if you want to. So if you set disable all macros without notification, then yes, P-code and Excel 4.0 macros do adhere to this setting. But a common misconception is that this setting actually blocks all macros, which it says. It doesn't. And if you're really interested into this stuff, I advise you to watch our DerbyCon presentation of last year and our Troopers presentation of last week, which are complementary to what we told today. But the basic summary is that trusted documents, trusted locations, and trusted publishers always have priority over this macro setting. So if you can have a document to be either a trusted document, which is just a registry setting somewhere, which you can abuse, or whether it is on a trusted location or signed by a trusted publisher, then it will always run. So that's why there's my answer, yes and no. There is a big caveat here, and in the presentations that I mentioned, we show some angles on how you can abuse that. Does that answer your question? Cool, thanks.
What is your experience been with Office file processes? For example, Apache Point, they have Office binary as well. What is your experience been with?
That's a really good one. So the question is, what is our experience with Office file processors, which are in various projects, both open source and closed source? I don't think we've ever seriously looked into that.
No. So interestingly, I started with these fields and these CVEs. We submitted them for Word. The patch came out for SharePoint as well. So we already saw that, we didn't really look into that, but we saw that apparently that was for SharePoint as well. So processors are in different areas as well. So but it's interesting research.
Yeah, and my gut feeling is the specifications of the Office file formats, but also of the macros, they are so difficult, that's one. They are ambiguous, like Unicode versus ASCII, etc., that's two. And they are also largely undocumented, while still those undocumented parts are being used by Word and Excel. So from my perspective, it's a recipe for a mess from a processing perspective. So
although I don't know
really good, really interesting angle.
I'm not sure which processors support macros, but that's, thanks for the,
Yeah.
we have some homework to do to look into that, thanks.
All right, if there's any other questions, feel free to come over here, or we'll be happy to answer them during the rest of the conference. Thank you again for your attention, and we hope to see you again. Bye.